Hello, welcome to another great interview from the Cloud Report. I'm Friederike, Editor-in-Chief of the journal, and today I'm talking with Jurlind Budurushi from Cloudical and Archis Gore from Polyverse about cloud security and our partnership. Please introduce yourself, guys. Who wants to start?
Archis first.
Oh, thank you. Well, I'm Archis. I'm CTO here at Polyverse. Before this, I used to work at Amazon, and then before then Microsoft. I'm what I like to call like a cloud native person because my very first machine I ever ran was on the cloud, right? I don't remember. I mean, I hear tales of times when people had racks, but I've never personally in my entire career touched a rack. So my thinking, obviously was influenced as, of machines as these abstract things that we rent and they come and they go away.
Great. So my name is Jurlind Budurushi, and I work as head of security at Cloudical. I'm working at Cloudical since almost 2 years now, and I'm very excited because I'm learning every day new things. Before that, I was new to the cloud native ecosystem, so I'm maybe the opposite of Archis. So I'm trying to learn every day. Before that, I was working as a consultant at Deutsche Telekom Consulting in cybersecurity projects, and before that, I was working at the university, the Technical University of Darmstadt, where I finished my PhD on usable security.
So, and why are you together here? What is your common topic or your related topic?
So I'll answer that. So what we do at Polyverse is we fundamentally we are a data-driven company. And so we look at all the CVEs, we look at all the attacks that happened in the last year. We look at trends in what kinds of attacks are up and coming. We look at what are people complaining about. So like we look at a lot of data, right? And then what we do is we look at the top big problem, the second big problem, third problem, that kind of thing. And then we ask ourselves, how can we solve that? And why that matters is, a lot of times when we have a hammer, everything looks like a nail, right? And sometimes it's great, but sometimes the problem is, we build solutions in the world that don't fit in the way the problem is, right? And so with that, we identified that the first problem in the world that we noticed was memory safety, right? And Microsoft had a big press release last year that said 70% of their bugs are memory safety issues. Chrome said the same thing. Google Project Zero has a spreadsheet of the actual attacks, the real 0 days that happen every year. And if you look at that spreadsheet year over year, there is one constant, which is about 70% of all of the real 0 days that actually happened in the world are memory safety issues, right? So like the data is what drove us to then build the very first solution we have, which is how can we solve the vulnerability, or how can we mitigate the attack that is caused by these issues. And so consequently, our very first product, the flagship product of our company, is called Polymorphing. And what we do there is we recompile all of Linux, all of open source code, right, on the whole world, every distribution, and we can recompile it as much as once a day for every single machine on the planet that subscribes to us, right? And we can do this infinitely scalable, and we can do it very efficiently and cheaply. Now, what does that recompiling do, right? The easiest way to think of it is it hardens that OS, right? It basically takes the code that's out there, but by re-rambling it, by reordering, register memory location and function addresses and PLT tables and all the things that keep the binary functioning exactly as it should, but they can be reordered, they can be rewritten in a different way. By doing that, an attacker who has like this one attack string If you think of like a script kiddie, right? They build a proof of concept, then they publish it on GitHub or on the black market, and then they just run it across all instances, right? Well, that just doesn't work anymore, right? The cost to build that attack is constant for every instance that we build, which means if every machine was scrambled uniquely, the attacker is literally paying that 3 months to hack into one machine if they have access to that machine to start with, right? So it becomes this very, it just becomes this very fun inflection, right? And on the user side, all they have to do is run one line command. And so that's our flagship product, right? Then we have like, other fun stuff in the works. One of it is open source called polyscripting for PHP. And what we do there is we, just before a PHP website starts, like WordPress or Drupal, we generate a brand new grammar. A brand new programming language is created. And then the whole WordPress or Drupal or PHP application code is transformed live into this new language. And then it's run, right? So like it's interpreted just fine, 100% accuracy, right? 100% correctness. But if anyone injected any JavaScript or PHP code, it just doesn't run because there is no PHP, right? And so like that was the number 2 attack, which is code injection, right? And Equifax is a great example of, they were hacked by a deserialization bug that injected some third-party code. And so that's what we do. Those are the 2 things that we have on the truck today. And then we're, of course, going down the chain, right? The next big one is XSS, and I have some crazy ideas there, but we won't talk about them. But like the second part of your question, which is like why Cloudical, why are we integrating, how are we integrating, right? And the real honest answer, right, is security is the one thing that works on my machine is not enough, right? It's like a common developer saying, right? Oh, it works on my machine, right? So what? Right? It has to work on your machine and everyone's machine and every machine on the planet, right? That's when it's evil. So, we love when we can partner, with friends like Cloudical, and we can bring this to people and we can make this usable and consumable, because like behind all the corporate bullshit, I am at heart a person who wants people to feel safe and warm and happy. And I always get a thrill when people benefit from it concretely in the real world.
From Cloudical's perspective, why and how we collaborate with Polyverse?
What I'd like to mention is, as Archis already discussed and mentioned, one is their background technology that they are using, which is, in terms of security, as it was explained, it provides a possibility to stop attacks from scaling. So it gives people, as we are people at the end of the day, the time to think and to solve their problems with, let's say, more time and solving the problems and not shifting them. So this is what I think it makes also the technology very interesting. In addition to that, we think the same, so we have the same mindset when it comes to, we'd like to provide something to the outside world to make it easy, usable and consumable. And this is what VanillaStack is doing from on the other side. It's providing people the opportunity to use a cluster, a productive ready Kubernetes cluster, and also other layers on top, and also other tools integrated with just some clicks and up and running within 40 minutes. So this is something what we are thinking the same. In addition to that, we at Cloudical also see security as an holistic approach. We would like to see security from the different layers and not just one, let's say, product. So we don't see security as a product, but we see security as a process, and we see security as an integrated continuous process. While VanillaStack is starting from the Kubernetes layer, we are aware, so we are not closing our eyes and leaving our customers or people out there and saying, okay, so the problems below that are only your problems, but we are continuously searching in how we can provide solutions out there and make their life easy and feel more comfortable and safe.
Yeah, I'd actually like to add something on the other way around. So I love that Cloudical is focused on usable operations and usable security, because on the other side of this, it's flowing backward now. So when we started like working with Cloudical, we actually had a need to move something we call the build farm, the thing that rebuilds all of these Linuxes. That thing needs to be portable, because customers now want it, and we were having a hard time because it's one thing to just say that you have Kubernetes, right? And YAML is just like a C calling convention, right? But those specific APIs still need to be supported, and someone needs support. And now we're actually looking at VanillaStack as a way, to move our build farm on top of, so that we can take that entire thing and we can move it, onto bare metal or onto, different public clouds or on-prem, wherever people want it. So, so that meshing of mindset goes both ways.
Was it a challenge to integrate the polymorphing into the VanillaStack, or was it easy going?
I would say everything, it's somehow a challenge, but it was as easy as you would use both technologies at the end of the day. Meaning that as you can install Polyverse just by one line of code that you type, it's the same has been integrated into VanillaStack, so you just have to check a button by using Polyverse if you want to do so. So it's completely transparent to the end user. This is, as VanillaStack is open source, anyone can have a look at the code and see the Ansible playbooks which correspond to that, and see how this has been integrated from a coding perspective, which is not a secret in that sense. So at the end of the day, we just kept that easy of use and easy for and transparent to the end user for doing that.
You mentioned Kubernetes, so the polymorphing is working on the Kubernetes layer, but is it also working on the tools or the integrated software on top? Jurlind mentioned that you can build a whole stack. Is the polymorphing is working at the whole stack?
So today, I believe the integration is on the nodes, the individual worker nodes. And so the nodes themselves are polymorphed. Now, on top of that, actually, in the middle there, Jurlind and I were just talking about that we, from our side, we do support it. But like I said, today it works on my machine, right? But now we will work with Cloudical to make sure that it works everywhere, right? So that it is then true security and not just my machine security. And so we have various ideas on, so we do scramble it. Just, to answer the first question is, we scramble all of those packages, all of that code. But how can people benefit from it with just one checkbox, right? There's ways to do it, and we're thinking through them and working through them.
Cool. So we need to stay tuned and to look what is happening in the next month and years.
Yep.
From a security standpoint, what is Polyverse or the polymorphing changing when you click on the button or if you don't click it? What is the difference?
Perfect. I can, what? I'm actually going to share something. This should be very fun, I promise. Can you see this Firefox window?
Yes.
Perfect. So we're actually going to disassemble two binaries. One is without the checkbox and the other is with the checkbox. And we're actually going to explore those differences. If anyone actually wants to play with this tool, it's all open source and there is a link to GitHub, and it's hosted at analyze.polyverse.com. It's an entire, we basically took Capstone, the disassembler, and we compiled it to JavaScript. And then we hosted it in the browser. So this is all client side. So this thing can disassemble like any executable search object files from any platform, any architecture. And so we'll basically, it's disassembling. And here's the disassembly of like libc from upstream Ubuntu. And these are all the functions, and and then when you scroll down, oops, here's all like the assembly language code with the addresses and the type of gadget, right? And so on this side, we can actually load a different one. And here's what happened. So first of all, like each any two pairs of executables or packages that we build have this mutual difference between them. So now some symbols, like the libc versions, are at address 0, and so they fall in the same place, and so they're red. Danger. How dare you, right? It's like, I already know this address. I know I can find the symbol at address 0. I'm just going to go there, right? And then when you start into the function export table, you start realizing that all of these addresses on both sides, not only are they different in the binary, but the offsets between each of them are just a little bit different. So this is how the functions are reordered, right? Which means if you broke ASLR and you broke into one libc, you have no idea where all the other code is, right? So that information leakage is entirely defeated, but then it gets more fun. When we go into the instructions, it's even more intense, because some instructions are, so if it's a white background, what that means is this instruction does not exist on the left-hand side, which means we totally took that instruction out and replaced it with a completely semantically identical, performance identical instruction, but it's not even the same. And any computer scientist watching know that comparing any two Turing complete programs for semantic equivalence takes the lifetime of the universe, right? So no one can like look at these instructions and go backward and say, what do these look like on this side, right? It's just like an impossible problem to solve. So we just made the attacker's life like extremely difficult. If they were searching for like some fun code to call, they just wouldn't find it, right? And then where we cannot, then we move them. And when we move them, they're moved by different offsets. And so we measure that. It's like if one instruction moved by an offset of 2, then the next one has to move by an offset of 3, and so on. And so then you have no comparative understanding of the two binaries. But here's the key part. The number of gadgets, each of these instructions is called a gadget, and it's like this reusable piece. It's like, think if you bought a clock radio and then you opened up that radio and then you took out the clock and used the clock by itself and used the transistor by itself or the speaker by itself, right? That is how most attackers work. What they do is, if they want to create an attack and they need one clock and they need one heating element, then they take, on your system as a clock radio, as a coffee maker, they take the clock from the clock radio, they take the heating pad from the coffee maker, then they take, one thing from here and there, and they assemble it live in memory so that you're not injecting any code. And that's called a fileless attack. And what we do is we make that clock look different, right? So it might have Roman numerals, or it might have, a different language. And so an attacker has no idea what they're trying to do. But the gadgets are they're the same number, similar number. And what that means is we haven't injected any code, right? We may have ordered it differently, we may have rewritten it differently, but there are no hooks, there is no gunk, there's no agent, there's nothing that's running. that we've injected. So this is like a clean file. And that is, and then if you click this, there's a beautiful graph that pops up and it shows you, the entropy quality of how well did we do and things like that. And so that's really the difference between the two. But it's happening entirely seamlessly. You have no idea it's happening, but you're being protected just preemptively.
Yeah, it was really fun.
Yay.
Thanks. And from just maybe a last question from Cloudical perspective, why it is for you important or interesting to include the polymorphing into the VanillaStack?
Well, polymorphing into the VanillaStack. So we are including polymorphing. We try to include, and that was the point that we were discussing before in between, to see the further steps. Seeing security as an holistic approach. Of course, that what Archis just showed is just exciting, fantastic. So I love it. I'll play around with it. So I see how I will spend my next weekends. But from that perspective is that you still need to do your own homework. So by keeping, let's say, default configuration passwords on your system, well, polymorphing, as Archie said, it's not the hammer and everything looks like a nail, but it's a very specific technology and tool that provides you security in, well, with regard to the majority of the issues and challenges or security vulnerabilities that are out there. So it gives you a very good comprehensive support and security and protection. Nevertheless, the layer of the security process is continuous, and you have to monitor and you have to do the configuration and you have to think about the different layers going up to the user, where we then talk about awareness and behavior. So this is also something that has not directly to do with technology, but it has to do with education and trying to educate and make and enable your users to behave, to be aware of security challenges and also to behave securely. So by looking at that, we see Polyverse as one of the gadgets out there and the specific tools out there that will benefit everyone that will use VanillaStack. They would be able to have that protection. So with just one click, but it's always good to understand that that one click won't solve you and all the issues, but it can give you some protection, very good protection.
Great. Thank you. So thank you for the information and your time.
First, thank you for having me.
Thank you for the